Hello, this is David Brannigan. I'm in second year in computing in Dundalk IT, and this is my submission for the MathsCA one. So, what you'd asked us to do for the first one was that an object moves in a straight line from the point and at a constant speed from the point 1 to minus 13 when time is equal to 0 to the point 11:17 6 seconds later. So the first part of this was to find the equation of the line, and you do that first by finding the slope. So that's y2 minus y1 over x2 minus x1. And so in this situation, the slope is equal to 3. And the formula for the equation of the line, y is equal to mx plus c. And you get this from y minus y1 is equal to m times x minus x1. And so for this, I used the point 11:17. And I got the equation as equal to y is equal to 3x minus 16. So step 2 was to put time into the equation by making x equal to t. So the object moves 10 units along the x-axis and 30 units along the y-axis in 6 seconds. So the formula for the movement of the object along the x-axis was 10 over 6 times t plus 1, and the formula for the progress of the object along the y-axis was equal to 5t minus 13. And so then I plugged them into this table, and it gave me the location of the object for each second between 0 and 6, and it told me where it would be, and then it gave me this table, or this graph. And so this is it at the start, and then this is it at its finish. And then the second task was an object. It was similar to the first one, but at this time it's with a circle. So an object is initially at 7,6 and takes 90 seconds to complete a circular motion of radius 7 about the center point of 0,6. So from there I've marked down some important pieces of information. So the center is equal to 0,6, the radius is 7, the time is 90 seconds, and from that we can get the speed, which is 4 degrees a second, because 360 divided by 90 is 4, and then the starting point is 7,6. So from that I was able to get the equation. So 7, which is the radius, cos. So I put cosine first, which will make it go anti-clockwise, because we didn't specify or the question doesn't specify as to whether it should go anti-clockwise or clockwise. So in this case it's going clockwise. And then 4t, which will give us the speed, so that it goes at 4 degrees per second. And then 7 sine, 7 again for the radius, and then 4t for the same reason as over here for the speed, and then plus 6 will give us the center of 0 and 6, because there's 0 out here and there's 6 out here, the y. And then I was able to get this table. So as you can see, x is equal to 7 cosine 4t. So that gives you 7, 6, and then all the way through the minuses and then back around. So 7, 6, it ends again on 90 seconds. And here's a graph of that. So it starts here. It starts here, sorry. At 0.76, travels around here, and then back to 0.76. So you also asked us a couple questions. To create a straight line motion, you have both x and y increased by a coefficient neither by sine or cos. Wave type motion is created by having either x or y increased by a coefficient and the other by sine or cos. Circular motion is created by having x and y increased by sine or cos. By having both x and y increased by sine or cosine. And then you ask a couple questions about circular motion. So the radius in circular motion is controlled by the multiple in front of the sine or cos, which was seen in the last time, that it was 7 sine and 7 cos. So the center is defined by the amount added to or subtracted from the sine or cos. So in the last case it was 0 and 6, so it was plus 6. And then the speed is controlled by the multiplier in front of t, last time it was 4. Changing sine and cos will change where it starts. If cos is first, it will go anti-clockwise, and if sine is first, it will go clockwise. And so then on the Excel spreadsheet with all these 12 questions. So the first one, the x is equal to t plus 5 and y is equal to 4t. And then I graphed it out here. Or no, sorry, I put it in a table. So this is 0 seconds and this is 20 and this is the coordinate of x and the 80. So what the top table here is that the orange is the movement along the y-axis and the blue is the movement along the x-axis of the object, and then the bottom table here is the final line. So it starts at 0 and 5 and then finishes at 25 and 80. Oh no, sorry, it starts at 5 and 0 and starts at 25 and 80, or finishes at 25 and 80. And so again here, this time it's an oscillation, I believe, because it's just, it has one wave and one, and there's no movement along the x-axis. It's consistently at the point 2. So it can be seen here that it goes back, that it starts and then goes back and forth. So while it has the wave here, it doesn't have the wave on the x-axis, so it's just an oscillation. And then in part 3, we have x is equal to sine times t, and then y is equal to 5 minus t. So we can again see the movement along the y-axis with the orange. Yeah, the y-axis with the orange. No, sorry, the y-axis is the blue, and then the orange is the x-axis. And then we see them both waves here. It's the same formula here, but this time with the sine t and cos t, it means it'll result in us getting a circle of radius 1. And then the difference with this circle and the last one is that it has 3 sine and 3 cos, so that we know it has a radius 3. And it's going in a clockwise direction. And then this is a similar circle to the last time, except it finishes in 180. Yeah, it takes half as long because the speed is, it's double the speed, so it only takes 180 seconds, as seen here by the 2t. And again, it has a radius of 3. And this time, it's a circle that's moving at a speed of 1 degree per second. And I have it going up in multiples of 15, so there's, and then it starts here at 0 and 5, and then goes around in the clockwise because sine is first. And again, this is just another similar circle, except this time it's going anti-clockwise. And this one is different because it has plus pi in the t, so it's not going to be 1 degree per second. It's the 15 plus pi or 30 plus pi multiplied by 5 sine, or cos for the y-axis. And then in this one we have the first circle that's not going to be on the 0 and 0, or the center point won't be on 0 and 0, it's on minus 3 and 2, because over here we have x is equal to cosine of t minus 3 and y is equal to sine of t plus 2. And then we have, over here we have 2 cosine t minus 1 for x, and then y is equal to 1 plus 4 sine t. And so that gives us more of an oval, because the height for the x, or the radius for the x, is different to the radius of the sine, or for the y side. And it gives us a center point of minus 1 and 1. And then for the final question, the x was equal to sine is equal to 3t, and y is equal to cosine 2t. So that gives us neither a wave or a circle, it just, because one of them goes further, the x goes faster than the cosine, so we end up with this shape instead of a regular shape. And that's the screenshot, or the screencast. Thank you.